Hi everyone, a very good afternoon. So how many of you want to improve your customer experience, right? I'm sure all of you, right? That's a given, right? So today we are going to talk about, I'm Gaurav, by the way. I head data engineering at Poshmark, and we're going to see how Poshmark accelerates growth via real-time analytics and personalization. Hi, Raghu, over to you.
Thanks, Gaurav. I'm Raghu Mannam, Solutions Architect with AWS. I mostly work with late-stage startups in the Bay Area. In fact, some of them have actually gone through IPO. My focus areas are mostly security, automation, DevOps, analytics, machine learning, cloud optimization. And with that, let's get started. So as Gaurav mentioned, all of us are interested in growing our company's revenues, right? So, and one of the approaches, a strong foundation for that growth, is improving customer experience. How do we improve customer experience? Customer experience can be improved only if we understand the customer well. You know, if we are able to, spend time with the customer, either in some form, with that knowledge, we are able to address the customer's requirements. So understanding customers means essentially understanding their choices. Nowadays, it's not like in the past where every customer now has many choices, and each customer has their own set of choices, and also those choices are frequently changing. So given this landscape, the main principle here is customization is actually very helpful in improving customer experience. So I wanted to tell you this when we were preparing this presentation about how to grow the revenues through customer experience. I was reminded of my first job about 40 years ago when I graduated with a EE degree and started my first job as a LSI manufacturing engineer, chip making engineer, first job. And when I started, my first assignment as part of our team was how to customize IC logic gates, logic gate chips, logic arrays. So that project was based on programmable logic arrays. So in IC design, we keep depositing layers of silicon, one on top of the other, with these interfaces acting like transistors. So in those days, about 40 years back, so we had to make different IC sets for different customer requirements, typically their inputs and outputs. So what one of our mandate for our team was, come up with a way where we can improve customization so that we can use basically one IC design process or one IC manufacturing process to cater to multiple customers' requirements. So the approach we took there was, talk to customers, get the truth tables. Truth tables are basically, okay, this is the set of inputs I have, and these are the set of outputs I want. So we would manufacture up to all the layers, and the very last layer we would not implement with the chemical vapor deposition, CVD, as we used to call it. So that layer we would actually customize for customer requirement and then do the metallization and package the chip. So basically, like 99% of the work is common for all these customers, and that one layer was customized. And so what I mean to say here is the principle of customization to grow business and to improve customer experience is really quite ancient. So that's very same principle. However, some things are different here. So what is different? There we had about a dozen or so customers. We could meet with them face-to-face, understand their requirements, get their truth tables, and then make the change for them. But now, for example, like Poshmark has 80 million customers, or for that matter, others may have, 1 billion customers. So how is it possible to stay in touch with our customers when we have such a large number of customers? How is it even possible to have a dialogue with our customers so we can understand their choices? The question is, and that's the question. For that question, the answer is yes. Yes, it is possible to have a dialogue with the customer. And today, Gaurav is going to show us how Poshmark implemented that capability. So really, the more I think about these things, digital transformation is essentially achieving the same goals that we did earlier, but through digital techniques. So how staying in touch with our customer through digital techniques essentially is this, has given birth to this real-time analytics. And we are going to dive intuitively how we make that happen. And we are also going to dive into the details of the various technologies that help us make it happen. With that, let's move on to the, okay, you got it here, sir, sorry. So we have an agenda here today. Gaurav is going to introduce Poshmark. Then he's going to talk about some of the business challenges that they faced initially and how they were trying to address it through batch computing, batch analytics. Later, the same problem was addressed through real-time analytics and how it has actually helped the company. What was the ROI and some of the benefits which were actually measured by them. He's going to discuss them. With that, Gaurav, thank you. And here.
Thanks, Raghu. So I'm sure you know Serena Williams, but she is one of the early investors at Poshmark, and she is a board member, and she's also one of the strong believers of sustainable fashion. On the other side, we have Manish, who is our founder at Poshmark. So what is Poshmark, right? Poshmark is the leading social marketplace for e-commerce, for fashion. We deal with fashion for men, women, kids, pets. We have more than 80 million users at this point, and that brings in the social community that we have. By combining the strength of physical connection and the ease of shopping at e-commerce, we're bringing in Poshmark all together. Right? That's what we do at Poshmark. So what are our users doing at Poshmark, right? So of course, like any other e-commerce platform, we are allowed to list items, yes. But apart from that, we have the whole social connect where people can like these listings, comment over it, and not only share your own listings, but you can share anybody's listing that gives a complete connection with the social audience that we have, right? Apart from that, of course, you have the purchases, and you have a feed navigation and things around it, right? So let's get to why data at Poshmark, right? At a very high level, all the decisions at Poshmark are driven through data, whether it has to do with our advertising, whether it has to do with new feature releases, or whether it's our homepage altogether, right? All of these are driven by data altogether. We collect more than 1 billion data points each day, and that amounts to thousands of terabytes at our data lake. We add in like thousands of data points every second to our real-time business health monitoring system with end-to-end latency of less than 50 seconds that allows us to monitor our business very closely, right? So what are the business challenges to begin with? Of course, like any other company, the growth was the first question, right? Then there are other things like we had to deal with compliance, and then we had to figure out how to reduce fraud, how to reduce spam content, and overall the goal is to improve the seller, buyer, user experience, and we're going to see how we did that. Before we deep dive into other things, let's get to how Poshmark's initial data structure was, right, or the data architecture to begin with. On the left side, like any other company, we have some of the apps. It's on mobile, it's on the website, and from there on, we have a backend system that runs on Ruby. I know Ruby is old, but yeah, we still run on Ruby. And we have our transactional database on Mongo. But as you all know, you cannot run any form of analytical queries on a transactional database. It doesn't matter, right? So for that on, what we started with is implementing an in-house CDC that captures change on a daily basis and puts it to our data warehouse, right? Airflow manages all of our schedule, dependency, and things around it. But at the end of the day, all of the changes from Mongo are transmitted back to our data warehouse on Redshift, right? Once the data is there on Redshift, we also collect all the data from our partners, advertisement partners, attribution partners, tie them back all the way into Redshift so that you can do more involved analysis, right? From there on, let's talk about the most interesting thing for the today. We have our clickstream data. What I mean by clickstream is we have click events, view events, order events, like event. All of the things that happen on our system are captured as individual facts, and they travel into our single source of truth that we have in our Kinesis. from here on, we have multiple different consumers consuming this data. The first one is Druid in this case, right? So Druid, basically, it's a time series database. It helps us collect all of these events, aggregate at 60+ dimensions, and then we can monitor our business health with latencies of less than 15 seconds, which means that if a like happened, we're able to see it on the dashboard in effective immediately, and if there is any softness in the business, we can immediately monitor it, right? The other thing that we have is that from the same data store, or data set, Kinesis, what we do is we store all of the raw data back into S3 in Parquet format, partitioned by event date, so that it's available for all the further analysis, right? Apart from that, we have a bunch of different ETLs, scheduled hourly, bi-hourly, daily, weekly, monthly, and so on, right? And all of these ETLs work either on Redshift data, they work on S3 data. Predefined business requirements are met using these ETLs, and they aggregate this data and shove it back into Redshift, right? So Redshift becomes our primary data warehouse here. And from there on, we have multiple different tools that leverage power of data warehouse and present it to the end executive team. So we have Looker. And apart from Looker, we also have a lot of ad hoc tools that we use. We use Databricks. We use EMR, Jupyter Notebooks, and a bunch of other things to do all that ad hoc analysis. The ad hoc analysis happens both on Redshift and on our S3 dataset. I'll give it a second. So what are the business challenges to begin with, right? One of the first challenges that we had was latency, right? We wanted to get to a much better latency so that we can react faster to our customers. At the same time, being able to react faster means that we could not only provide a better experience, but save a lot of money if we were dealing with fraud, right? The other thing is that we wanted to build in a lot of reusability. We were looking into building a lot of features for different entities that we have within our system, and we were unable to get both of these requirements to fit into the existing solution. So what we did is we headed to AWS with our problems, and they helped us.
Thanks, Gaurav. So Poshmark approached us and said, hey, we have our current batch processing analytics solution. It's helping us, but it's not where we want to be. So when they approached us, I met with them together with some of my architects in analytics. And at AWS, we have multiple ways of engaging with the customer in order to help them speed up their designs and implementations. So we have what are known as immersion days. We have workshops. We have specialist engagements. But they're all mostly confined to a single-day engagement. We have what is known as a data lab program, which is a multi-day, 4-day engagement. And I'll tell you, the real, as it says, come with an idea and live with a solution. It's exactly similar to that. So how does it work, and what is the purpose of that program? If you ask me, the main point here is we have architects who are highly specialized and who have engaged with solving customer problems, some of them hundreds or even thousands of customers. And they have built up a tremendous capability. So the point here is, bring those folks and make them collaborate very closely with our customers like Poshmark, with their architects. So 5 architects from Poshmark and Gaurav, and 4 architects from AWS, and then myself, 5 architects from AWS. We sat together at a table and closely collaborated and accelerated this design process. So typically, we hear from our customers that when they have an idea and they want to implement a design for that, it may take months. But we also hear from them that when they engage us, that process is accelerated to like a week or so, or sometimes even less than that. So that's the type of capability that this data lab program brings to the table. I'll go in a little more detail about the program. So initial step of the program is we qualify. We talk with the customers, architects, and decide, hey, whether what they're trying to achieve is something that a data lab program can help them or not. Once that qualification is made, we do some pre-lab processes. That is basically talk to them, understand where their data is, understand what type of infrastructure exists on AWS or elsewhere to process that, and who from the customer's team is going to engage with us in this design. So the design actually is done by Poshmark or our customers, and our architects are there to speed up and guide them as and when they get stuck. At the end of the program, we come out with a blueprint for a design, which is what we did in this case, and that's what Poshmark has used to further enhance. So I wanted to talk a little bit about the problem and give you some intuitive feeling for it. So this picture from Forrester, we can see here that the value of the data that we collect very rapidly falls off almost exponentially as time passes. So remember, as I was introducing, I said that customer experience can only be improved if we understand the customer very well and we are able to offer them the choices that they need in a timely and in a timely manner. So understanding customer is not that easy in a world when we have 1 billion customers, for example, 1 billion consumers or so, right? So we have to take advantage of the digital techniques that are available to us. So if you operate here in this reactive mode, where you are responding to a customer event within minutes to hours, that's where the batch section falls basically. You are able to understand the customer, but you are not able to have a conversation, a dialogue with the customer. So having a dialogue with the customer is extremely valuable in implementing, enhancing the customer experience, right? So we can have a dialogue with the customer only when you are able to operate in this, see that short time frame, which is like a couple of 100 milliseconds. So when the customer reacts, when the customer clicks a mouse button on an app or on a website, within a couple of 100 milliseconds, you have to understand what the customer wants, what is the customer asking based on that event. That has to be captured. And then we have to understand, okay, enrich that. Okay, customer, okay, you have an event, and I'm going to talk a little more about enrichment. We get a full scope of that event, and using that, we have to further use machine learning or some such mechanism to generate an answer to that customer conversation and respond back. That's how we are going to have that conversation. So how did we go about? So this is the business challenge, right? We want to have a conversation with the customer, and we have 1 billion customers, or in this case of Poshmark, we have 80 million customers, and we need to have a conversation with all the 80 million people or simultaneously, or to a portion of that in a simultaneous manner, right? That's where our digital analytics will come into play. So what are we talking about? We have an event, either on an app or on a website or some other event. So that event has a very tiny portion of information about the customer. It's maybe if the customer has a 10,000 dimension vector, that event is just 1 dimension. So just with that event, we can't do much, right? So that's where the process of enrichment comes in. With enrichment, you just take that tiny event, and then you use the rest of all the knowledge gathered about the customer from other sources, from like advertisers, like Poshmark has hundreds of advertisers. They each show a tiny glimpse of the customer, and you capture all of that. And then you create a model of that customer, a digital twin, as you call it, of that customer. Or in this case, we have multiple business challenges. So we create models of the customer, we create models of the products, we create models of the security threats. So those are some of the things. That's how we go about. So in AWS, we have this process called working backwards. So we first determine, okay, where do we want to be? And from that, we work backwards to determine what needs to be in place for us to be at our final destination. So in this case, the final destination is achieve our business goals, improve personalization, reduce fraud, reduce bot activity, reduce account takeovers, provide better personalization, all of these. So we started from there, and we started working backwards, and we put together a timeline. Okay, what is the budget we have? So from the time we capture the customer event, that has to be captured, brought into a clickstream server. From that, it has to be ingested, and someone has to consume that event, and then enrich that, and then do a prediction on that. So all these steps are there, right? So, and then all these steps have to be, remember, in order to have a dialogue, it has to be, the answer has to be returned to the customer in about half a second or less, right? 500 milliseconds we are talking about. So the ingestion process itself, we broke it down and said, okay, we were asking for a little bit more, but Poshmark was adamant. They said we can't spare with more than 100 milliseconds for that. So in 100 milliseconds, we have to consume the event, capture the event, consume the event, and then some budget for enrichment. And they gave just a few milliseconds for that. And then, prediction, we were going to talk about that. Gaurav is going to go into a lot more detail. So this is just some intuition for you, how we put together the solution. So as I was saying, each event is like a small puzzle in a million piece puzzle, or you can think of like, that's why I drew that picture. So one event is like that piece, and you take that little piece, and then you enrich it. Means, how do you enrich it? There is information in other sources, for like these advertisers. There's information in their MongoDB. There is information in their Redshift. There is information about this customer, one little dimension spread out in all over the world, in every little area. So those we call the enrichment sources. We pull from there. We put together this puzzle in the process of enrichment. And then we take that enriched information about that customer or event. And from there, we basically convert that into a representative model for generating the features. And we take these features, we do dense embedding of these features. From there, you use neural networks to create a prediction, and then use that prediction back and return to the customer. So that's the process, right? So I mentioned those three: ingestion, enrichment, and predictions. We can move on. We are going to dive deeper into each of these areas and how we put together the solution. So, but for the ingestion itself, we had multiple choices. One choice was Amazon Kinesis data streams, which Gaurav has shown earlier that they're already using. The advantage of that is it's a low cost. It's typically 40% lower cost than Kafka. It has its limitations, and it is also highly fine-tuned for certain use cases where it does very well. Most of our customers choose that. But in this case, we needed an extreme low latency budget. So with Kinesis, you get 200 millisecond consumption budget. And if you go with additional fan-out capabilities, you can go up to 70 milliseconds. But with Kafka, you can go up to 30 milliseconds consumption budget. So that's why in this case, we decided to go with Kafka. And then for enrichment, we decided to go with the Flink, which is basically a managed version. The Amazon Kinetics data analytics is a managed version of Apache Flink. So the advantage there is this enrichment process is a very complex process, right? What are we doing? We are taking one piece of puzzle and we are coming up with the whole built-in puzzle. Visual, just for intuitively, you can think of it like that. Even though it's not as simple as that, but it will give us the idea, right? So there are so many steps involved in this enrichment process. And the way we do it is, with Flink, we get a nice high-level language, even SQL, or Python or Java, whatever, any language that we prefer. we can write our application, run on it in a nicely parallelized manner. And we are going to, Gaurav is going to talk about further breakdown of that enrichment process itself. It's a tremendous, what should I put, lot of thought and design and expertise has gone into this, putting together this architecture, both from AWS side as well as from Poshmark side. We are sharing with all of you that. And then, of course, Firehose is for, storing the events in any of those stores, whether streams or lakes. But let's talk a little bit more. Here, I mentioned that, going back, actually, I mentioned that we had a choice, right, between Kinesis, Amazon Kinesis data streams and Amazon, or Kafka. So in that choice, basically, we talked the advantage of Kafka here, which is 30 milliseconds. There are a few other differences here. More complex management in Kafka, easier management up there, lower cost in Kinesis, a little bit typically higher costs here. But other things, both have managed options through AWS. So we decided on Kafka, right? So next step, with Kafka, we have again two options. Poshmark could deploy open source Kafka on EC2 or K8 Kubernetes and run it that way. Or Poshmark could use Amazon managed streaming Kafka, the Amazon MSK version. So here, I had discussions with Poshmark team, and I presented both options for them. And let's see whichever option they feel is appropriate for them, they can. So with the managed Kafka, what we are getting is, we are getting a lot of additional capability, which Poshmark didn't have to implement themselves, right? For example, you can deploy it in a VPC, of course, that you can also do it in open source Kafka. Here you can use CloudWatch metrics and CloudWatch logs for monitoring the performance of the cluster. You can use KMS-based encryption for securing the cluster. You can use IAM-based authentication and authorization for the APIs, which is a big advantage. It's simpler to use because the rest of their applications are running in AWS, so that advantage will be there. Then for security audit trail, for compliance reasons, you can use CloudTrail, which is nicely integrated with the managed version of MSK. And again, mutual TLS you can do through Certificate Manager for additional security between clients and the cluster server. So all those advantages are there. So with those advantages, Poshmark felt that managed Amazon version of managed Kafka is a better fit for their requirements in this case. So with that, we put together a high-level solution. Basically, as I was mentioning, we have to capture that little tiny glimpse of the customer information, and we have to enrich that. Here we are showing multiple enrichment sources where additional pieces of customer information is spread out. We take that, and then we create a model, a digital twin of that, and then you further refine it. You do additional processing based on your business need, and then you send it to your ML, neural network, to get the prediction. I'm going to give it to Gaurav to talk in a lot more depth about each of these steps.
Thanks, Raghu. So at a very high level, let's go from the blueprint to the final design that we came up to, right? So on your left side, you will see the same thing. We have our mobile applications shoving all the data or clickstream data into application servers and clickstream servers. From here on, these events, here is the change, or here is the key piece, right? We move to Kafka first so that we can get to a sub-second latency, right? 2, we introduced a large enrichment framework. We'll get into a lot of details about what that enrichment framework is, right? But then if you look at it, the events going into MSK, you have an enrichment piece which is run over Flink. So Flink is a true event-based processing system. We moved away from batch-based system or micro-batching to true Event-based processing, because of the latency requirements, like micro-batching cannot satisfy these kind of needs, right? So Flink helps you do true event-based processing through a high-level language. But from there on, Flink makes multiple different calls to different microservices that we have. And then all of these are then enriched in place and then send it back to Kafka. Now, from this Kafka, that acts our now unified source of information for all the different applications we have. Now, I know we have a lot of applications, but I think we'll go one step at a time. We'll go with 3 different examples today and see how do we fit to the bigger picture back again, right? So let's talk about 3 use cases, right? One, we want to talk about compliance. How did we deal with CCPA, or how did we deal with de-identification of user information? How did we deal with removal of IP? Or we'll talk about how did we did fraud mitigation, right? And then we'll also talk lastly about personalization. How did we get to personalization using all of this, right? So the first one, right? How did we get to doing the compliance, right? Now, when we get the events to our first Kafka server, right, or the first Kafka topic, what does Flink do is that we have a microservice that will go and answer you for any IP. So when you hit it with an IP, it'll give you back all the geo information. So the Flink will make sure that it'll make a call to the microservice with the IP, get all the relevant information, put it back to the event, and get rid of the IP, right? The other microservice that we have is all the de-identification. So it'll give all the user IDs that are relevant for that event, put it to the microservice, and get back all the de-identified information, right? Now, once all of this is available, package it back and ship it down. This way, we were able to do all of this in real time. We'll deep down again back to enrichment because that is more interesting. Now, how did we get to such low requirements in terms of latency, right? Because that is the key. Now, Kafka itself can get you to 10, 20s of MS latency, but enrichment is complicated, right? So what we did at the very beginning is that we made sure we split all of our enrichments as independent microservices so that none of them talk to each other, right? To begin with, so Flink makes sure that it calls all of these enrichment services asynchronous in parallel and has a timeout, of course. And once it gets back, it'll combine all of this information at one shot and then push it back. So that was the first design approach that we took. And in terms of technical details, we started using gRPC. That gave us a huge benefit. We started looking at HTTP. We were somewhere down like 25 MS and things like that. And then we said, let's look at gRPC. And even with SSL in place, we were able to get to somewhere like 3 to 5 MS with gRPC for every call. That's significant for us, right? The next thing that we looked at is load balancer. You want high availability on microservices. Since all of these microservices are independent, high availability became a huge concern. So what we did is that we initially tried out a load balancer, and load balancer works in general, but then it had its own sets of latencies. What we did is we went back, we re-engineered how we call our microservices, and we made a smart client where the client is aware of all of them. It just keeps a track of all of the microservice servers that are available from time to time, and whenever one is available, it just read out to another one, right? That way, what happens is that you get a client-side smart load balancing with no jump in between, because load balancer is a killer here. And the third thing that we added as an improvement is we added a caching layer. Some of these backend systems are not amazing at giving back at this response rate, right? So for example, Mongo, although we hit secondaries in our Mongo so that we don't affect the customers, even then we were not satisfied with the requirements that we had. So what we did is we added another caching layer. We had some business logic around it, which makes sure that we have some kind of TTL, cleans it up at some time. But at a very high level, we use Elastic Cache or some sort of Redis cache. They'll make sure that it is cached there and it does not hit the original source each and every time, right? So this is how we were able to get to doing de-identification, removal of IP, and things like that. Let's talk about second use case, ATO, account taken over. How many of you remember LinkedIn breach, right? I'm sure it's a famous one. A lot of you do, right? So what happens in such breaches, or a lot of breaches, is that your information is exposed outside on the world, and all the hackers try to take the same set of credentials, assuming that as humans we would use the same credentials across all the different sites on the planet, right? So although your website is not hacked, if somebody has used the same credentials on your site, the hackers use the exposed credentials and try to log into your domain, right? So no mistake of yours, as long as your customers use the same set of credentials, we are screwed. That's what happens with an account takeover. Basically, a hacker tries to use the credentials that are leaked outside from a very different site and tries to use the same set of credentials on your applications. They get in and then try to do all sorts of transactions that are happening. In Poshmark's case, people started placing orders on the credit cards that were belonging to the users, which was sad, right? This had dual problem for us. One, it had financial implications because we were, of course, refunding the buyer. At the same time, we were refunding the sellers because a lot of times sellers ship the items itself, right? The other problem was that we had a terrible customer experience, right? You can imagine how bad of an experience is this for the end users, given, oh, as a seller, I ship, and now I'm not going to get that money, or that's the thought initially. Or as a buyer, I think that, oh, somebody got into my account and placed an order which I never did, right? So that's a terrible user experience, and that's why we said, let's look at how to get to account taken over, right? What we initially had was a batch approach. It worked well. We had developed a ML model that was batching out at almost every 2 hours. We were not doing it more frequently because of the cost concerns itself. So what we started with is a batch approach, and it worked for some time. But then, the value of that data kept going down as we further moved down our schedule, right? As we went to 2 hours, the amount of things that we could prevent just kept going down. So we wanted to make sure we go up the ladder and we make sure that we're able to prevent these kind of frauds effective immediately, right? So we said that let's start at the top of the funnel, let's act on it immediately. So what we started with, let's start with the left side, right? So if you look at the left bottom trajectory, what happens is that we have our enriched data set that we spoke about all this while. We have all the enriched information. And from there on, we have developed a Flink-based feature store engine. What is a feature store engine, right? Let's start with what is a feature store, actually. A feature store is basically something that can store different attributes of different entities that you have in your ecosystem. For Poshmark, the entities are like user, buyer, seller, listing, order, and things like that. And what are the different kinds of attributes? Attributes can be like, what is the last login of that user? How many times has this user been active for last X days? How many times this listing was shared today? How many times was this listing liked today? And things like that. So all of these features make a very important contribution to how we can do predictions and how we can do fraud detection, right? So let's come back to feature store engine. So what is a feature store engine? Feature store engine is a system that takes care of collecting this data, aggregating in the required format, and making sure it can push back to our feature store. In this case, we had written all of our feature store engine logic as part of Flink, which collects all of the data from enriched data source, pushes back to Elasticache, which is our feature store, and which can be then consumed downstream for multiple different applications. This is just one of the applications that we have. That's a very independent pipeline, right? So from the core, what happens is that you have your stream, and then we have introduced another application, which is a demultiplexer or a rerouter. I'm not sure a lot of you are from EEE or EC background, but basically, what does a rerouter do? A lot of customers have this problem. Your stream is interesting. You have a lot of interesting data, but I'm interested in a subset. How do I deal with it, right? So we developed an in-house rerouting system. What it does is that on a configuration basis, it selects the events that you are interested in. For example, certain people are interested in, or certain kind of workloads are interested only in order events, and certain are interested in impression events. For example, if I have an application for advertisement, it's only interested in the impression events and page view events. On certain type of events, I'm interested in orders. For example, in this case, I'm interested only in order events because that's what I want to look at to prevent and fraud order, right? So this multiplexer, what it does is it helps you break down your large data set that's incoming to specific data sets that are required to different queues so that not everybody has to start reading the whole stream that you have in-house. Of course, it adds some latency, but it compensates against how much you have to read. In our case, we have billions of events, and our orders is a much smaller portion of it, right? So from here on, what we do is we select order events, and we push it to a queuing system. From the queuing system, we have a basic queue worker. We have it on Ruby. But what happens here is interesting. We get all of the order events. For each order event, we look back our feature store, and then we say, get me the user attributes, get me the order attributes, get me the listing attributes. Once it takes up all of these attributes, it makes a call to our ML model that's hosted on SageMaker, and it predicts, OK, this is a fraud order, this is not a fraud order, and with some percentage of confidence, right? With this confidence, then we decide if we should notify the backend system, which is fairly straightforward, right? So we push it back again to a queue, which goes back to the backend system, and backend system takes care of dealing with, should they stop the order, blah, 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 everything around it, right? So that's how we deal with fraud order. Of course, the queue worker also publishes some of these metrics outside so that it can be further used for analysis. It goes back to Redshift, Looker, and all of those things forward, right? So how did ATO benefit us? So as I was initially telling, the model was amazing. What we built was able to predict a lot of orders. At the same time, we were able to, even though we were doing batch-based system, we were able to prevent 45% of our fraud orders simply because the model was great. And even within 2 hours of batch window that we had, we were able to prevent 45% of the ATO attacks that we had. We're still struggling with the other 55%. Once we moved to real time, what happened is that we were able to predict 80% of our ATOs and prevent them. That's the beauty. So that improved our customer experience significantly, and it also kept the whole seal in our financial debt because we were paying both our buyers and sellers, and with prevention of ATO, we saved a lot of money there, right? So let's talk about the third use case, LTR, learning to rank. It's a weird term, I think so. But what is learning to rank? How many of you realize that when you search for things on Google, what I search, if I search for the same keyword and you search for the same keyword, you'll get very different results, right? Although it's the same page or the same site and the same keyword, it's all based on personalization. Now, yes, it has its own issues, but it is still very interesting because when I search for, let's say, a keyword, it'll probably give me something around the lines of coding. And when my friend searches for it, I'll probably get you'll get something around fashion and things like that, right? Although it is the same keyword, that's just because of how Google has trained your persona and how it can deal with what you are looking for. So that is what is LTR. It's basically for the same result set that we have, how do you re-rank the top results and give it to you so that you get the most personalized results that are relevant to you, right? At a very high level, that improves the customer experience because if I am used to buying, let's say, Gucci and somebody else is interested in buying H&M, and if I search for a red shirt and I get the relevant ones, I would be more inclined to purchasing them. At the same time, I'm more happy because I don't have to scroll and start looking for them, right? So it gives me more personalized results. So let's see how did we get to that at Poshmark. On this one, let's start from the other side, right? So we spoke about a lot on the feature store on the previous slide, right? So we have our enriched data stream coming in, and from there on, we have our feature store. And now this feature store is reusable, as we spoke about in our previous slide. We have multiple different entities that are available. We have user entity, order entity, and all of that. In this case, what we have is user entity. It stores attributes around what were your recently liked brands, what were your recently liked brands purchases, what were your sizes that you purchased, what were the sizes that you liked, what are the things that you commented on. We have more than 100 signals that contribute back to your user entity or your user feature store so that we know what you are interested in, right? So we store all of that against every single user, and yeah, that's a lot of data, but yes, cache helps us. It serves as a very fast lookup as long as we are just looking for a given user and not looking for a bulk. At the same time, what we do is we also store all of the listing information that's there. We vectorize listing on what's their brand, what's their recent likings that have been done, what kind of CIs that they belong to, or what kind of groups they belong to, and everything is stored again back in Redis again as a listing set of features. Now, with the power of both of these, what happens is, let's say somebody searches anything on our system, right? It, of course, hits the application server. Now, instead of getting 40, 50 listings that we generally get to show end users, what we do is we get thousands of listings, right? We pick out, let's say, 1,000 of listings. We send back all of that to our ML model that we have trained, and along with all the information that we have for you as a user and all the information that we have for every listing out of the 1,000, right? We combine both of these data sets, and then we re-rank all of the listings that are relevant just for you, right? So out of the 1,000 listings, the 1,000 listings in general are common, right? But then what gets re-ranked, the top 50 ones that we are going to show you are then again personalized just to you, right? So with this, what was the benefit at a very high level? We were able to provide recommendations. The click-through improved at the top of a funnel by 8%. That was huge because that kept traversing down, and that was a significant improvement all across. The other thing was that we were able to include new listings for our personalization. Earlier, with any kind of batch-based system, what used to happen is whenever new listings came in, we were not able to recommend them simply because we didn't have any information about them in our feature store. They were delayed, and you can't re-rank unless you have any feature information on them, right? The same was with new users. When new users came in and our batch system were still not up about that user, then we had absolutely no way how can we deal with them or how do we personalize for them. So this significantly helped us work on new listings and new users. And in all, we were able to improve our customer experience, and we were able to grow top of our line. So this was the overall architecture that it looked like, right? Well, once again, try to fit in everything together so that it makes a lot of sense, right? We went through 3 use cases and deep dived a lot. So we have our application systems. We have our mobile app, web app on the left side, and then we start with our application servers. Now, both of these systems throw in all of the events to our Kafka topic. From our Kafka topic, we have Flink that acts our true event-based processing engine, works through multiple different enrichment sources that we have. We have sources like Elasticsearch, OpenSearch, we have Redshift, we have Mongo, we even have external APIs, all of them being cached, right? And from there on, we move to enriched topic. So all of these events, once they are enriched, we get them to enriched topic, and we have multiple different consumers. Once it moves to, let's take the first example, Druid, right? Now, earlier we were not able to slice and dice any data with geo information, but now since the enriched data is available, we're able to slice and dice in real time our business metrics, business health metrics by geo, which means that if you are interested in a certain state, city, we can narrow down all the way and understand how business health is being impacted because of a certain release, certain feature. Is it impacting a certain location or things like that? So that was the first application. We're able to put all of our raw data back to S3, which is now enriched. So all of our analysts now no longer have to join for the majority of use cases. Earlier, they were spending a lot of time trying to read this data, pick other data sources from Redshift, Mongo, here and there, join it, which takes a significant amount of time. Now, this solved our need for data analytics because a lot of this information is now available in place in the event. First, our event was only this much, and now it's this large. So a lot of our queries are just cut down, and they are able to slice and dice within just the event, and they don't have to look outside. Right? So it's the same Parquet data, but now with a lot more information. And then we spoke about Rerouter. Rerouter helps us select certain sets of data. It also helps you transform the data to maybe pick certain columns and things like that, push it down to different queues. This has humongous application because you can then do a pub/sub mechanism at a very high level that if a certain event happens, I want to be notified and let me deal with it, right? So this opens up a lot of features for our end engineers where they say that, hey, I'm interested when there are certain likes happening on certain kinds of listing, notify me. If there are order events happening, notify me. And now we have gone to a step further where we say that, I want these events, but why don't you build an enrichment and then send me so that I don't have to do anything? So that way our workers are fairly light. The enrichment happens up front, and everybody is able to make use of this enriched data that we have, and they're able to simply work out of it. The last one we spoke about is our feature store engine. We use Flink for that, and we make sure that all of the data is collected and aggregated, transformed in some form, and stored against all the different entities that we have, and we use Elastic Cache for that. I think now this diagram makes a lot more sense than earlier, right? I think, yeah. So I have a quote from our VP. Amazon Managed Streaming for Kafka has made it easy for us to set up, maintain, and scale Kafka clusters, otherwise which would have been very difficult. MSK definitely makes it easy for us. Here are some additional resources that we have. But I think with this, you got some insight into how can you leverage real-time data analytics for improving your customer experience, whether it has to detect with fraud or a bunch of other things, right? So I hope you had an interesting time. Thank you.
Thank you. Thank you.